All right, very good evening, one and all. Is there something up with the chat? Let me just check it out. What it is? Do we have any chat issues? Yeah, I think the chat is not there, right? Just give me 1 second, everybody. I'll get the chat up as well. Uh, just give me 1 second. I think sound check is done. Let me just get the chat up. And yep. 1 second. I'll get the chat up, everybody. Meanwhile, do keep your answers about what do you want to do today? Which questions would you like to discuss today? Keep your questions and answers ready. I know it's a festival, but we'll do a quick revision and then we'll get started. So just give me 1 second. Let's get this out. Yeah, here we go. You'll have to refresh your page once. Just give me 1 second. I'll tell you when to refresh. I think you can refresh your page now. You can refresh your page and you will see the chat as well. I'll also refresh my page and you'll see the chat available for all of you. Sorry for that. Sorry for not having the chat up at the start. For those of you watching on YouTube, you will need to log in though. So the link is in the description below. Anybody who's watching on YouTube. So anybody watching on YouTube, link is in the description below. You can check there. All right. All other students, you can join the chat right now. Do say hi. Right. Please say hi when you log in so that I know that you can hear me. All right. Great. Hey Harika. Hi Tejishwar. Hello 1297. Hi Jamin. Hey, good to see you. All right. Oh yeah, you guys did send some emails also yesterday, right? Okay, I see. I have myself have forgotten about the emails, but no problem. We'll look into the emails as well. Let me pull out some of the problem statements that you have sent. Okay. I just remembered from Jamin right now. So thanks, Jamin. I'll be looking into some problem statements also. 1 second. Hi everybody. Good to see you all. And please discuss about Elevate. Not discussing about Elevate right away, but we have organized some mock tests for everybody. Mainly in Elevate, I think where people are lacking is the MCQs. MCQs, they're going to ask you a little bit more like, HTML, CSS, JavaScript. That's the kind of stuff they're going to ask you in Elevate. So just make sure that you're ready with that stuff. Otherwise, your usual stuff, like, for example, things like coding. I mean, we've covered many such coding questions. So for coding and all, I think you can it'll be a little bit higher than TCS Ninja. That's all I would say. A little bit higher than TCS Ninja. That's all I could say over there. Otherwise, yeah, I mean, if your colleges want, we can do a separate Elevate session as well. But yeah, I think there's a lot of time issues. Okay, I'm just opening up some questions for all of us to do. So just also checking the email sent by everyone about the different question levels. So 1 second. Yeah, system's a bit slow today. Just waiting for that. I just able to see only yesterday recorded session at Edyst portal. How can I see past recording? Yeah, I think you have to be a paid student of Edyst. That's how you can see it. If you're not a paid student of Edyst, if you are a paid student of Edyst and you can't see, just write an email to team@edyst.com. Will help you. Just write an email to team@edyst.com and our team can help you with why you're not able to see, basically. All right. Okay. All right. Yeah, somebody saying position of man. 1 second. That one. Okay, cool. I got one of the questions. Okay. Sorry, my system's a bit slow because I'm doing all of these things together. So just give me 1 second. I'm just going to get all of this up. Okay. All right. Finally got one question. So all right. Okay, so somebody's saying we have confusion for each I from 0 to 5. So how many times will this loop run? If you're doing for each I from 0 to 5, how many times will that loop run? That actually depends on, is it 2 5 meaning including 5 or less than 5? So typically when people say that, they mean, I mean, again, it depends on people to people. That's why I am very specifically, and in my view, it will be equal to 5, but you have to, I'm not sure what is meant with that in that question. So that's okay. So this is somebody's question. I'll just pick that question up. I'm just trying to pick up if there's any other question. So I'll put that question also here. I believe somebody had sent another question. Jamin, had you sent a question? I do not see it. All right. So I'm not getting another question. I'm just getting this one. It's sent, is it? What is the name of it? 1 second. Let me just search here. Yeah, I got it. Never mind. I got it. Oh, you just sent it, is it? Just sent it, I think. Okay, cool. Feels like at least you just sent it. Okay. All right. Anyway, we'll take this also. Download. And download. Okay. So I'll take this one and some other ones. All right, everybody. Thanks for waiting so long. Now I think we'll be faster. So this is one statement, and I believe this is a continuation of this statement. Was this one? Yeah, the continuation of this. All right, cool. Awesome. So I'm just closing this here. Okay, great. So, all right, everyone, let's start with what we have planned for today. A lot of people have asked a lot of things, so we're going to do one by one. I'll tell you the agenda for today. What's the agenda, right? So just bear with me here. Agenda, we'll go through one set of MCQs, right? Set of MCQs. For some of you have already done this, but for others, I'll just complete this. So we're going to go through one set of MCQs right now. We'll look at the questions you have sent, coding questions sent by you, and also coding questions, two remaining coding questions on Edyst previous TCS questions. Right? So these are previous TCS questions, and look at 2 remaining coding questions that were there. So I'm just going to take that up. I'll start with the MCQs. Let's quickly pick up some of the MCQs over here, right? All right. So for that, I'll open up the Edyst platform and I'll take this up. Okay, here we go. And let me just bring that up. All right. Yeah. So in this MCQs, you will get your pointers concepts as well. Don't worry. We're going to discuss a little bit about pointers concept. And I have already discussed the pointers on Monday, I believe so. So just go and revise a little bit from Monday. I think it's Monday or Tuesday. Monday being 6th September, I believe so. Yeah, 6th or 7th September, I've discussed that. So you can go ahead and check that also, in addition to what we'll do today, right? Okay. So, and okay, let's look at this one. So for example, they've given you what is the output of this C code. As I was explaining on Monday, right? Whenever you're getting and give the output question, always start at the main method. So in this case, they have given you the main method itself, but generally speaking, most people like to read the entire code. Don't start at the entry point and then keep going ahead. Okay. So here what you have is the main method, right? And it says static int x is equal to 3. Now the entire point of static int x is equal to 3 is it will be initialized only once. So this is the point of static variables. A static variable is initialized only once, right? After that, it continues with its previous value. So the variable is not destroyed, it continues where it left off. Okay, let's look at it more closely. You have your static int x is equal to 3. That means x value is initialized to 3. X plus plus happened. At the end of this one, it becomes 4. X plus plus means x becomes 4. If x less than equal to 5, yes, x is less than equal to 5, 4 is less than equal to 5, I'll print hello. So I'm printing at least one hello. And then I again call the main function. This is recursion. So I again call the main function. It again goes to static int x is equal to 3. But here, do note, x will not become 3 again. X is not going to become 3 again. It got initialized already. So it's going to skip this step. It's going to take the previous value of x, which was 4. It's going to do x plus x plus plus. X becomes 5. Is x less than equal to 5? Yes, it is. 5 is less than equal to 5. So I'm going to print hello again. And then I'm again going to run the main function. This time x was 5, it becomes 6. Again, this is not executed again. It was executed once and that's it. So now x becomes 6. It will not enter this loop or this condition. So it's not going to again recurse further. So that main function is not going to be executed. It goes back and then it goes back. So you're only printing hello twice. So the answer here is D, printing a hello only twice. The value obtained in the function is given back to main by using which keyword? Again, this is a simple theory-based thing, return function. So using the return keyword, whatever values obtained in the function, you return it back to where you had called it from. Okay. All right. Which of the following statements are correct according for the given declaration? Int function int, double function int function float. Okay. A function with same name cannot have different signatures. All right. A function with same name cannot have different return types. A function with same name cannot have different number of parameters, and all of the mentioned. All right. So for C specifically, all of the mentioned are correct. Right. A function with same name cannot have different number of parameters. This is possible in Java, though. So they have not clearly clarified it. But if it was just talking about C over here, I would go with all of the mentioned, though I'd check it up again. But yeah, a function with same name cannot have different number of parameters. You can have different number of parameters. Actually, that's entirely the point of polymorphism. But do remember that C is not OOP, and I don't believe polymorphism is a feature in C. Having said that, do double check this one. But in Java, C++, and Python, you can have same function with different number of parameters. It's actually a good question. Can you do it in Python? C++ and Java you can definitely do. Python you may not be able to do exactly, but you can do method overriding over there. So in classes, you can still do method overriding. So there's still polymorphism exists in Python. And no, you can actually also, by the way, you can also do the same range with different number of parameters, just like the same function, just like the range function, right? So the range function takes different number of parameters. So C++, Java, and Python, different number of parameters you can take. In C, you cannot. A function with same name cannot have different return types. This is actually kind of true. I'm just trying to recall, is this the case in Java and Python and C++, all of them? But in C, you cannot definitely do that. And a function with same name cannot have different signatures. Again, in C, you cannot do this. Basically, that whole polymorphism is not there in C. So all of them are correct over here. So we'll go to the next one. What is the return type of the function square root? I believe it's double. So the return type of the function square root is double. Okay. Next one. All right, we'll come to pointers, don't worry. What is the output of the following return? What is the output of this code having void return type function? So again, what are we doing here? We're going for void main. Always go with main. Int x is equal to 0. X is foo. Printf modulo d x. Right. It's going to be compilation error, because remember, C, C++, and Java are all strongly typed languages, meaning that they really depend on your data type that you're returning. Now, if you're returning 1, it will give a compile time error because your return is a void. So for a void, you cannot have a return 1, right? If it was int, that was still fine, but a void you cannot have. So it's going to give you a compile time error over here. Okay. What's the output of the following code below? We have void main int k is equal to m, calling the m function, and printf modulo d k, right? So again, it's expecting an integer over here, right? And you are returning a void. Like there's no return only here. So again, this will be a compile time error, right? This is not going to be a what do you call, not even going to get compiled. It's going to be a compilation error, because here you request an integer. You're expecting an integer, and you said int k is equal to m. Not only here, in fact, here itself you're saying int k is equal to m. So it's not possible, right? Yeah, let's look at a pointers type question here. Okay, so just again a quick revision on pointers. What does it mean to be a pointer? A pointer is, okay, so pointer refers to the address of a variable. So you have a particular location, and the pointer refers to that particular address, right? It refers to a particular variable location. So for example, you have something like int star ptr is equal to, and in fact, actually, let's say int a is equal to 5. Then you have int star ptr is equal to and a, right? So what this and a does is saying that wherever a is located, right, I want to know that location. That location I want to hold in int star ptr. And it's not like the pointer can't move. The pointer will move from one position to another. A pointer will move also, right? So that's the entire point of pointers. They actually give you access to the memory. Can a pointer further have another pointer to itself? Yes, you can have a pointer to a pointer also. That's also very much possible, right? So yeah, that's another thing. But yeah, this is the very basics. We'll look at the question to understand more. For more details, I'd covered this on Mondays and Tuesdays class. So please go ahead and check those classes as well. All right. So what we have here is, start with the main function. Int star k is equal to m, which is what I'm calling the m method, right? So I call the m method over here. And when I go to the m method, what it's saying is it's going to return a pointer itself, right? That's this method signature here. It's going to return a pointer. So it says int star p is equal to 5, right? Int star p is equal to 5. That means p points, or rather the location stored in p is 5, right? That's what we're trying to say here. Location stored in p is 5. 1 second. Does that make sense? Location stored in p is 5, and we are saying return p. So we return p, and then we are printing star k. Star k will dereference what is in k. All right, this is interesting. Let me just check this once. So you have, I believe it should, 1 second, int star p is equal to 5. With 5 is not an address actually. 5 is not an address, so it's going to store 5 itself. And when I do int star k is equal to m, it's going to return p. And if I do star k, it should print 5. It should ideally print 5. But why exactly is it printing 5? Because this int star p is equal to 5. What does int star p equals to 5 mean? Int star p equals to 5 would mean that it is pointing to an integer, but it's not pointing to the address. Now, if we say address of 5 is stored in P, yes, correct. Yeah, you're right. Yeah, you're right over there. Yes, absolutely correct. Address of 5 is stored in P. So because address of 5 is stored in P, you return P and then you're dereferencing it here. Had you just done printf modulo P and P, if you had just printed the pointer, you would have got the address of P, right? Address of 5. Very good. Thank you so much. So you're storing the address of P in this. So address of 5 in this. You return P, which is the address of P, which is the address of 5. And I'm printing here star K. I'm printing a star K, which is I'm dereferencing. What does dereferencing mean? Go to that address and print what is at that address. That's what star K is doing. Hence, I print 5 over here. Okay. All right. Let's look at another one. How many times will we print simple way to code? So int main printf simple way to code. This ideally should go, it will not go infinite time, it will go till stack overflows. So now, what does it mean by till stack overflow? See, all of your function calls are stored in a stack. All of your function calls are stored in a particular stack so that you know that which function has to be called. So internally, your compiler, or not your compiler basically, but when it's executing, it stores all of the function in a stack call. Now, it cannot go infinite times because infinite times means that it will just keep going forever, right? But rather than that, it's actually just going, it will stop when the stack overflows. And so hence we'll say it will go till stack overflows. If you did not have this option stack overflows, then you can choose infinite times, because what you're saying is it'll keep going till the program crashes. That's what we mean to say. All right. Okay, this is a switch case thing. So in a switch case, do remember that I have here int a is equal to 5, b is equal to 7, and I'm saying switch a over here, it is case 5 print I am 5. Okay, there's no semicolon here. So for that itself, I feel it's an error. Case 5 this, case 7 this, default printf I am different, and then return 0. Yeah, just because there's no semicolon here, I would say it's an error. Otherwise, if that was the case, we would go switch a, right? We would have picked I am 5. Generally, I would have picked I am 5, but there's no semicolon here, so that has to be an error. We'll go for an error over there. Okay. Ashima wants to print a pattern which includes checking and changing a variable value iteratively. She decides to use a loop condition. Which of the following should she use as the body of the loop condition is executed at least once, whether the variable satisfied the entering condition or not? So this is in a do-while loop. In a do-while loop, what you do is you execute it once and then you check the while condition. So at least you executed once. So that's the point of a do-while loop. So if I submit an end, yeah, we got 10 on 10, but there's nothing big in that because I kind of knew all the answers. So that's 10 on 10. But yeah, that's a little bit here. For more on pointers, I know there was one question on pointers, but I mean, this is the level generally you can expect. There is one really great concept of, constant pointers. So I just ask you to check that up. There are multiple, tutorials on that. Would highly advise you to check the difference between const star char ptr, right? Const star const rptr, right? Char ptr, right? Or other char star ptr, right? And also const char star ptr. So these are all 4 different things. One is a constant character. One is a pointer to a constant character. One is a constant pointer to a character. One is a constant pointer to a constant character pointer, and one is just a character pointer. Right? These are 4 different things. Just check it up. There are multiple articles on this available, but just check this up. This is an important thing because this kind of a question can definitely come up for you in Ninja. I've seen it come up earlier. In fact, we had a similar question as well, I think, some time back. So I think you guys will be able to see that. 1 second, I'm just picking that up. Yeah, not sure. It's in one of the MCQs. It's in one of, I mean, we have over 710 MCQs. I'm not sure exactly where it is, but it's there. It's there on the platform. You can check it out. And this one we completed now. 1 second. Maybe I'll be able to find it. Just give me 1 second. No, okay. So I'm not able to see it exactly right now, but yeah, it's there somewhere. If you just keep searching, there are over 700 questions. So again, I don't know. It's like a needle in a haystack. But check the difference between these four things. It's a very important concept in pointers. So just check that up. And I did cover this back some time back. I think 2-3 classes back. So you can check it up there as well. All right, so that's a little bit about the MCQs. As we said, we look at it. I don't want to keep you long. Also, I know it's a festival for all of you, so and me. So I don't want to keep you long as well. But as I said, we'll do one set of MCQs. If there's a particular MCQ that you want to cover, let me know and I'll cover it as well. Let's look at some of the coding questions sent by you. So I'll just open one of them first and let's see. Right. You have one question. Can I share? Yeah, please do share it on the chat. Right. And if I'm able to take it, I'll take it up right now. Okay. Meanwhile, I'll take up this coding question. Sita is asked to print the second greatest element in the array. In case if the second largest element is not present in the array, print there is no second largest element. And if the size of the array is less than 2, print invalid input. Okay. So in this question, basically you have to print the second largest element in the array. And if there is no second largest element, now what is the case in which there will be no second largest element? There is only one element throughout, right? So there's only one element throughout over there, and that's what it will be. Okay. Somebody has shared one thing. Let me check it out. Okay, I'll come to that question. I'll just note that question and I'll just come to that one. Just noting that question down. Cool. I got that question on my system. I'll come to that one. All right. So anyway, let's come back to this. This over here. So you're supposed to find the second largest element. This is the kind of a question that I would expect, TCS Ninja to ask. Okay. All right. What are some ways of doing this one? Can anybody suggest? How can you get the second largest element in an array? Can anybody suggest this? How can you do it? I'll explain both ways, the Python way and the non-Python way. That is the shortcut way and the long cut way. But can anybody tell me how we can get the second largest element in an array? Any thoughts on how to do it? Do let me know any thoughts. If no idea, then you can say no idea as well. That's also fine. Sort a list and loop through the back. Yeah, okay, so that's the easiest way. Like, I can understand why you'd want to go for that. That's the most simplistic way of doing it. Yeah. So sort a list and yeah, just do like the second last element. Sure, that's one way of doing it. What else, everybody? The only issue is sorting the list, right? So if I do sort the list, let's say, for example, let's say I'm given something like second. So if I'm given a list, let's say like ARR is equal to 2719036. So your answer is 7 over here, second largest element. If I do like ARR.sort, this is the simplest way, and then I just have to print ARR minus 2, right? The second largest element will be here. Technically not even be the second largest element because there might be multiple elements. So for example, you could have 9 over here, right? So in this case, you'd have to just go from the back and figure out which is the first element which is not equal to the maximum element, right? You can do this in TCS Ninja and you'll be fine also. Actually, there's no problem here. You can do that, and what you'll basically do is max element is equal to ARR of -1, that so then you'll go for I from end to start. If if ARR I less than max element, answer is equal to ARR I, and then you break out here, right? So you'll start from the end. If it is the maximum element that you got, you continue. The moment you reach a place where it's like not the maximum element, you know it's the second max, you know that's the answer, you break, and all you need to do is print the answer. Okay, so that makes sense. I can just sort the array and I can get the second last element. Okay, not that there's anything wrong with this, you'll still get your answer. The only issue is you'll change the entire array. In your bid to figure out the second maximum element, you sorted the entire array and you changed the entire array. So the way to actually solve this one would rather be if I did something like this. Okay, if I did let's say I'm given that array, I'd do something like this. Max element is equal to, let's say, ARR 0. I assume this is the max element, and let me find out the maximum element. Okay, let me go ahead and find out the actual maximum element, which is for for I from 0 to end, right? I'll go if ARR I greater than max element is equal to ARR I, right? So I'll just say that. So I got the maximum element over here. Then I again go for, I'll say second max. I'll assume, or rather max 2, I'll assume is ARR, or let me just say max 2 is something like, let me just put like a number -1. You can just basically any number out there, a very less number. That's all I'm trying to say. That it's a number. Okay, and I go for I from 0 to end, right? I again go, now I check if ARR I is greater than max 2 and ARR I is less than max element. It has to be less than. So what we'll get is, we'll get answer here is equal to ARR I, and we'll print answer, right? What does this mean? I will go from 0 to end. I'll try to get a number which is greater than my current number, but it should never be as much as the maximum element. It should be less than the maximum element I have found so far, right? So it's greater than max 2, but it has to be less than max element, right? And so we'll take an example here. So let's say max element is ARR 0. You assume that it is 2. You assume that it is 2 over here, right? Now, second, this is just comments, right? So I'm just writing comments here. So you assume that it's 2 over here. You start from 0 till end. You check, is 7 greater than 2? Yes, it is. So your answer now becomes 7, right? So it's your answer is 7 at this point. Okay. You go to the next. Is 1 greater than 7? No, it's not. You don't update. Is 9 greater than 7? Yes, it is. Becomes 9. Is 9 greater than 9? No. 0 greater than 9? No. 3, 6? No. So your max element is 9 at this point. Then you got max 2 as -1. You again start from the start. Here what you're comparing is ARR I, that is 2, greater than -1? Because you assumed it to be 2, right? -1 is 2 greater than -1? Yes, it is. And is it less than, is 2 less than 9? Yes, it is. So currently speaking, your answer is 2. Next, you come with 7. Okay. Next, you come with 7. Now you're going to check, is 7 greater than 2 and is 2 less than 9? We always have to make sure that it's less than our maximum element so far. Is 2 less than 9? Yes, it is. Sorry, not 2 less than 9. Is 7 less than 9? If it is, then your answer is 7 over here. Like that for each number we check. Is 1 greater than 7 and 1 less than 9? No. Is you check with each number. Is 9 greater than 7? Yes, but 9 is not less than 9. So you will not update it. So finally, at the end, your second maximum element is going to be 7, and you'll print 7. Now you might ask, sir, but what if we don't have any particular element? Well, if you don't have a second maximum element, this will always remain -1. This max 2 will always remain -1, right? The edge case here is what happens in the case of let's say here in this given question, what happens if they're given negative numbers as well? So if you have given negative numbers, then what should I do, right? So I can't assume the second maximum to be -1 at that point. I should not assume the second maximum to be -1. Instead, I should assume something else. So you can just take a better guess of the second maximum. We just kept it -1 so that the next number that comes is greater than it. So there is this concept of negative infinity. You can use that, or rather, if you just don't want to do that, Simply speaking, what you can do is look at the you can take you can find the minimum element in the array and put max2 as minimum element -1, right? That's another way you can do it. If there are negative numbers in this array, you don't want to take max2 as -1. One of the other things you could do is you could just do -1 0 0 0 0 0. So just you are fairly certain that no test case is there that is this negative, right? Did you understand this? The person who shared this question, did you understand what I'm trying to say here? Okay, actually that person may not even be online, but did you all understand the logic of this question? Did you all understand? If it's clear, please say clear. If you understood. Do say clear, everybody, if you understood this part. Okay. Do you guys want like any other explanation on that? Let me know. Second. This time I'm not getting any answers, so I'm just waiting. Okay, clear. Super, super. Thank you. All right, small lag in you guys doing. So that's why. Let's look at the other coding question that you guys have mentioned. So yeah, so one person hands over a list of digits to Mr. String, but Mr. String understands only strings. Okay, this is 1 second. I'll just elongate it so that you guys can also read. Okay, but wait. I'll read it out, everybody. I know it's a little bit, the zoom is very off, but I'll just read it out. One person hands over the list of digits to Mr. String, but Mr. String understands only strings. Within strings also, he understands only vowels. Mr. String needs your help to find the total number of pairs which add up to a certain digit D. The rules to calculate digit D are as follows. Take all the digits and convert them to their textual representation. Next, sum up the number of vowels from all textual representation. This sum is digit D. Okay, if they have an input, that would be good. 5, 1, 2, 3, 4, 5. So this is the input that's given, and output is ONE, which is take all the digits and convert into the textual representation. Next, sum up the number of vowels, that is A, E, I, O, U, from all textual representation. The sum is digit D. Now, once digit D is found out, all unordered pairs of numbers in input whose sum is equal to D. Now, once digit D is found out, once digit D is known, find out all unordered pairs of numbers in input whose sum is equal to D. Whose sum is equal to D. Okay. So the input that's given here is 5, 1, 2, 3, 4, 5. How do you convert it to the textual representation? Oh, okay. 1, 2, 3, 4, 5. Got it. Got it. Got it. Got it like that. Okay. Next, sum up the number of vowels from all textual representation. That sum is digit D. Once I've done that, now once digit D is known, find out all unordered number of pairs in input whose sum is equal to D. And what's the output I'm supposed to give? Output lowercase representation of textual number of pairs in input that sum up to. Okay, got it. Got it. Got the question now. Okay, guys, decent question, right? So let's look at this. Again, it's a implementation heavy question. So it's something like this. I think you're only going to get digits first of all. And let's say you got the digits 1, 2, 3, 4, 5. Right? These are the digits you got. Textually, if you represent digits 1, 2, 3, 4, 5. Textually, this is how you represent it. Once you represented it textually, what you need to do is you need to find out how many vowels are there in this. Okay, you need to find out how many vowels are there in this. So here, how many vowels are there? There are two vowels. Is one vowel, only O. Here there are again two vowels, E, E. Here O and U, so two vowels. Here I and E is two vowels, right? So O and E, two vowels. 2 is one vowel. 3 is two vowels. 4 is two vowels. I and E is two vowels. So the D over here is called as the D over here is the sum of the number of vowels in each. It is 9. Sum is 9, right? Sum is 9. Okay. Now what I need to do after this is I need to find out how many pairs. It's not done here yet. Okay. So one second. Let me just again tell you what we have done so far. Number one is for all given digits, write their textual format. Okay. Once you've got the textual format, what we need to do is sum up the vowels present in textual format. Okay, once I did that, this is equal to D. Okay. Now after I've got D, what I want to do is I want to find out how many pairs sum up to D. So if I look at here, pairs, only pairs. I'm not talking about triplets or something. I'm saying exactly how many pairs are there that sum up to 9. There is only one pair that sums up to 9 over here. That is 4 and 5. No other number. Now you may argue that, sir, I can do 2 plus 3 plus 4, but that's not a pair, that's a triplet, right? So again, that's what I'm trying to tell you. Or you could do 2 plus 3 plus 1 plus 4, right? Or rather, sorry. But you get what I'm saying. 2 plus 3 plus 4, or there must be some other pair here, 2 plus 3 plus 4, or you could also do 1 plus 3 plus 5, for example, right? But what we're trying to say here is we just want the pair. So how many pairs there sum up to D? There is only one pair. So your answer is going to be 1. You have to write the textual format of this. So you have to write the textual format, which is 1. So your answer is 1. So your output has to be 1, O-N-E. Output has to be 1. Now let's look at some other questions here carefully. In this case, yeah, you can get these kind of numbers. All right. What are the numbers you can get? The output the input you're going to get is up to 100. Okay. And so you can get like 100 over here, 100 inputs. And within the inputs, you'll get something like starting from 1, 2, 3, all the way up until 99. This is mentioned in the constraints. In the constraint, it's mentioned it's all the way up till not even 99, up till 100. Yeah, it's up till 100. So from 1 all the way up till 100. Okay. Which means that if I had to, yeah. So what will you do? You'll take from, like, let's say in the worst case scenario, right? In the worst case scenario, what you're going to have is you're going to have to 100 elements, right? And those all 100 elements you want to sum up, right? And you want to figure out how many pairs are there that actually sum up to this value, right? So it's going to be an interesting problem over there. Okay. All right. Let's think about it. In the worst case scenario, let's look at this like this. Okay. Let's say each number. Okay. Before I go ahead, did you all understand the question? Did you understand these 4 steps that you're supposed to do? Did you understand the 4 steps you're supposed to do? Do let me know, yes or no, if you understood the 4 steps. Okay, great. So now our problem here is summing up the vowels that are present in textual format into getting to D. This is easy. Okay, this is easy. Why will this be easy? The first one is the difficult part. If we are able to convert each element to a proper textual format, then the second part is easy. Counting how many elements are there in a word is easier to do. Okay. The problem comes here where how many pairs are there, this to figure out. So there are 4 different problems all attached into one. Okay, this is how I would solve it. All right, first things first is I need to figure out how I'm going to, I don't need to figure out the textual representation of each number. Rather, I need to figure out how many vowels are there in the textual representation of each number. Okay, that is more important. Okay, now look at this, right? We have a similar question on the Edyst platform, so you may have done it, but I'll just show you. I know from basically for one, okay, for one it is just one vowel, so we can actually write down for one there's only one vowel. No, sorry, there are two vowels, O and E, right? So two vowels. There are two vowels here. For 2 there is one vowel. For 3 there are two vowels. For 4 there are two vowels, O and U. 5 there is two vowels, right? Sorry, 3 there is two vowels. Okay, 2 only one vowel. 6 one vowel. 7 two vowels, E and E. 8 E I. Yeah, so only two vowels. 8 is E I. 9 is two vowels and 10 is one vowel. Okay, we'll need to go a little bit further before we can generalize something. So let's look at this further. So let's say I tell you, starting from 11, how many vowels are there? E, L, E, V, E, N. 3 vowels, right? Then do correct me if I'm wrong. But 11, you have 12, 2 vowels. 13, 3 vowels. And correct me wherever I'm mistaking. 14, 4 vowels. 4 vowels. 15, 3. 16, 3 vowels. 17, 4 vowels. 18, 4. 19, 20. 19 would be N-I-N-E 2, yeah, 4. And 20, yeah, so this is the part where it gets simpler, is only one vowel, right? So 20 is only one. And you also have to figure out for 30, 40, 50, 60. So this is the last column that you need to fill. After this, it will become easier. Okay. So then you have 30, 40, 50, 60, 70, 80, 90, and 100. Okay. So for 30, there is 1. 40. Okay, what is the spelling of 40? It's 1 only. F-O-R-T-Y, by the way. So 40 is 1. 50, 1. 60, 1. 72. 80, 2. 90, 2. And 100, H-U-N. 2. So there are 2 vowels. Okay, so now you might be thinking, why did I do so many things, right? Why did I write so many things? So first things first is, if I know these numbers and how many vowels there are in these, I can extrapolate everything. Between 1 to 100, I can figure out all the numbers, right? How can I do that? See, between 1 to 10, I've got, 11 to 20, I've got. Every other number is going to be, let's say 33. I'll take the number of vowels in 30, I'll take the number of vowels in 3, and I'll add them up. Okay, 47. Take the numbers of vowels in 41, take the number of vowels in 7, 2. So there's going to be 3 vowels in this totally. 85, 2 vowels from 80, 2 vowels from 5. So 4 vowels completely. So if I know this, I can, whichever word is there, let's say there are all 100, 1 to 100 words are there. Just by knowing this, I'm able to very quickly figure out how many vowels are present in each. Okay. So you can write a switch case basically if you want to. When you get like, let's say you got a big number, right? So let's say you got something like 83. Split the digits. By now, everybody should know how to split the digits. 8 and 3 is there. This will be 80, by the way. So it will be 80 plus 3 rather, if you want to do it, 80 plus 3. 80 here would mean I have 2 vowels, and 3 would mean I have another 2 vowels. So there are 4 vowels. Right? So there are 4 vowels over here. Okay, like that for each number, figure out how many vowels are there just by using this map. Okay, this is the first step. So once I've got this first step, I can figure out D. That is, for I'll take a sum of all of these vowels. So I can figure out D. That's the first thing I can do. The second thing I can do then, now that I've got D, so because I had this, I just write the approach also over here. Right? Approach. Number one, figure out figure out per number how many vowels, right? And how will you figure out? Just from this table itself, you'll split the number into two halves, the tens digit and the units digit, and you'll figure out in the tens and the units how many vowels are there, and you're going to sum up them, right? So you'll figure out how many vowels are there, per number, sum up all the vowels. I'm going to sum up all of the vowels over here, right? And that will be equal to D. That is equal to D. Then next, what am I going to do? Once I've summed up all the vowels, now is the second part. How many pairs of numbers are there that sum up to D? I need to figure out how many pairs of numbers are there that actually sum up to it. That's a different question. So now I've got a target. I need to figure out how many pair of numbers are there that sum up to a particular D. Again, multiple ways of doing it. All right. The question is, given a D, how do I figure out how to sum up how many numbers are there that sum up? So one of the things you can do is, for I from 0 to n, let's say there are n numbers, right? For j from okay, so I think j will have to be from I plus 1 to n, right? What you have to do is you have to check if ARRI plus ARRJ is equal to D. So now this is a pair. You're picking a particular ARRI, trying to find out if there is any ARRJ along me that whose sum is equal to D. If there is, then I'll just do count plus plus. I'm going to do count plus plus. What you need to be careful of is, that same ARRI, it can form different pairs, right? Yeah, I think this will work. This works out, right? So because you're always checking with the next one, so this works out, right? So you found out how many pairs are there at this point in this way. Now, once I found out the number of pairs, I need to figure out what is the textual representation of that pair. Okay, so I need to figure out what's the textual representation of this particular pair over here, right? Now for that, I will need to do another thing. So how do I figure out the textual representation? The only way I can estimate, I can figure out the textual representation. Let's say this number has to be 57. So my output has to be 57. This is what my output has to be. Okay. But for me to even figure out how many possible, what are the numbers? Like, let's say, for example, it's 257. So I will have to write 257, right? Now, I don't know how I can write 257 because I have not accounted for 3 digits. For that, we need to figure out whether this D, how big can this D be, right? How large can it be? And how this count plus plus, how much can this go to, right? How many pairs can they be at? So assuming, let's say, if I had to actually take up all of the vowels, let's say in each element, let's just say, for example, there are 6 vowels in each, right? Let's say at max in every word there are 6 vowels. I don't think there will be, but in the worst case scenario, you can make a case that there might be 6 vowels in each, right? So if there are 6 vowels, then this can go up to 600. This D can go up to 600, right? How many pairs will be there? What's the maximum number of pairs that you can get that sum up to a particular number? It's a good point. How do we get that? Like, what's the maximum number you can get? Can you get 3-digit numbers? Okay. All right. But I don't think you'll get a 4-digit number ever. I think that's the simplest thing I can say, because it's just a hunch here. Let's say you have 600 as D, right? There will always be probably only 3 or 4 numbers that will actually sum up to this, right? So ideally, your problem is always going to be a single. The final answer is going to be a single digit number. So those of you who are lost, let me tell you again. Till this part we summed up the vowels and we got the textual format D. Now we need to find out how many pairs sum up to D. That's what we do. In our case, it was one pair. But how do we find out how many pairs will sum up to D? Well, as I said, we learn the for loop and we check the count, and then we express the count in textual format. So once you've got the count, print the count in textual format is what I'm going to do. But for me to be able to do that, I need to know how I can break this count down into a textual format. Right? Not too difficult, actually speaking. It's not really too difficult, because let's say even if it was 4 digits, what you're going to do is, let's say the number comes out to be A, B, C, D, E, right? Or let's say B, C, D, E, right? So let's say something like 1, 2, 5, 7. 57, we already know how to print it. 57, we already know how to print. We just did it, right? How will we print this 2? Simple, just do 200. And that 1 is going to be 1000. So here, all you need to do is get each digit. If it's a thousandth digit, you print the digit itself, 1, 2, 3, 4, whichever it is, and print 1000 in front of it. Then you get a 2. If it's a hundreds digit, you'll print 1, 2, 3, whichever the digit, and you'll print 100 over there. And then the 2-digit number you'll print however you want to, right? Like how you're supposed to, 57, 63, whatever, right? You'll print it that way. So that's how you would solve this question. Yeah, it's a bigger question, I know, but yeah, this is the kind of question you can expect in Ninja. It's just implementation. There's not much there. Can you all tell me if you understood this? Do say clear if you understood. If you've not understood, then let me know which part, and I'll explain it from there. But I hope you got the gist of this one. Where was this question, by the way, Jamin? Good one. I mean, is it in any placement test you found it, or on some other platform? So do let me know, Jamin, where you have found this question. But yeah, others, let me know if you have a doubt in this one. On Prep Insta. Okay, cool. Yeah, good level of question. Good question. All right. Okay, if we have 1, 2, 3, 4, we should find vowels for each digit 1, 2, and 3, 4, or digit or 12 and 34 individually. No, so you will never have a 1, 2, 3, 4. You will have number only till 100, and the numbers you'll get only till 100. So you need to figure out up till 100. So let's say given the word 99, you need to figure out 99 how many vowels are there. So you find out the number of vowels for 90, and then you find out the number of vowels for 9, right? And so you'll get it over there. Okay, cool. All right, please say clear if you all understood it. Please do say clear if you all understood this one. Okay, cool. We look at one more coding question, right, which is on the platform. So let me just break that. One second. Let me take a decent question. We'll wrap up with this one. 1 second. Yeah, there was also another pointers type question somebody had asked. So let me just take that one up also. 1 second, just pulling that one up. Give me 1 second. Yeah, it's a bit of a complicated question, but let's see it. All right, so 1 second. This is the question. It's a good question. 1 second. Just pulling up the question. Here we go. This is the question that somebody had sent me. All right. So cool. So what's happening here is we have const char star p, right? So this is a constant. It's a pointer to a constant. No, it's a constant character pointer, right? It's constant character pointer. This 1 2 3 4 5 can change. So it's basically like what we are saying is p points to the address of 1 2 3 4 5. P points to the address of 1 2 3 4 5. That this 1 2 3 4 5 can change, but this p will not change. P will point to that address only. It's what it means. Now we have q which points to p, right? Which basically means that it's pointing to the address of p. So that's what it means over here. And what we did was we said star q is equal to abcde. So we went ahead and star q was nothing but star q was nothing but what is in p const char star q is that star q is p. So p is now p will be equal to abcde over here. That's what this means. P will be equal to abcde. Now const char star s is equal to star p. So s is equal to, now this is a good point, what will const star is equal to plus p. P will not change though, or will it? Yeah, because p is here, or is it going to be the other way around? P is equal to this. I would say s points to bcde now. Technically speaking, s points here is what I would say, because you did plus p and it comes here, which would mean that p's values also change, but we said that p. Interesting. Okay, we'll come to that. Then p changed here, which is fine. We don't care about that because s is still pointing to that same place. And then we do star of plus s. So if you're doing that, then technically it's cde. And it's going to print c over here. I'm going to print c. If I run this, yeah, it does print c, right? It does print c. That's what it would mean. The only thing I'm getting the intuition for this. The only thing I'm trying to figure out is const char star p, right? That's what we're saying, which would mean that, just give me 1 second. Const char star p means that it is, yeah, it's a, no, sorry, constant is p is, it's an address to this, and it's an const char star p would mean that this is a pointer to a constant character. Yeah, network problem, no issues. 1 second. Give me 1 second. Yeah, okay. So, okay, I'll tell you the best way to figure this out. Okay. Yeah, I'll tell you the best way to figure this out. Right. What this means is this is a pointer. So if you want to figure out what is constant here and what is not constant here, or basically, see, after the star, we are talking about the pointer. Okay. So over here, if you notice, we are saying const char star pi. Before the star, we're talking about what can this pointer refer to. Okay. So just for you all to remember correctly, before star, what can we refer to? Or when we say, sorry, what can we, I mean, say, what can pointer refer to? After star, we mean to say what it's about the pointer, Okay. So if you say after star, it's just p. Had it been const char star, const ptr, const p, let's say it said this, then you'll have a problem because you can't change, right? You can't really increment of read-only variable p, because now what did you say? You made p read-only, you made p constant. So I can't do that. Okay. So before star, we're talking about what can pointer refer to. After star, we're talking about the pointer. Okay. So in this case, what we mean to say is p can refer to the address of a constant, and this 1 2 3 4 5 is a constant, right? So that's why it can refer to that. So it's fine. It's fine over there. Now we have const star q, which means that q is a pointer to p. That's fine. Then I did q star q is abcd. What it's meaning now is q now points to abcde. Q points to the address of abcde. That's what we did. Q will point to the address of abcde, which means that what was there at that point, p was there at that point. So p is also pointing to. So what you're saying is p and q are pointing to abcde over here. Very specifically, p and star q are pointing to abcd. Very specifically. Okay. Then we said const char s, const char star s is equal to plus plus p. So p can move. That's what I'm trying to say. P can move, but what it can refer to is only a constant. P can move, but it can be referred. It can refer only to a constant value, right? So I did move it, but when I did move it, it went to B C D E. Okay. Now what happened? P changed to this, but our S is still pointing there. That's the entire point. P changed, but S is still pointing to B C D E, right? And then when I did plus plus n plus plus s, which because s can move by one element, so I did plus plus s and then a star, it dereferenced the, so it went from B C D E, it went ahead to C, and it dereferenced that, and it became and it printed that value on it. So it printed C, right? Hence, when you run this, you will end up getting C value over here, right? That's why you got C value. Does that make sense, everybody? The major thing to remember, which I also get confused about, is always go back and say, before the star, what can pointer refer to? After the star, it's about the pointer. If there is a const, means the pointer cannot move. You cannot do p plus 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 s. You cannot do any of that. Okay. Before the star, it means if it was const char, it means it can only refer to constant characters. It cannot move refer to anything else. For example, if I did something like char c is equal to a, something like this, right? And then I said, you know what, p is equal to and c. I don't think it'll allow us to do this because, okay, it did allow us, but why did it? Yeah, if I did this and if I did c is equal to, let's say, b, will it allow us here to do that? Okay, it still allows us to do that. But why though? P cannot point to a non-constant character over here. All right. But if I had done something like P cannot point to, So if I had done something like that here, char c is equal to a, and I think it's converting this by default. It's converting it. It's upgrading it is what it's doing. So if I had done something like and c over here instead, will it run? Yeah, it did run. Very interesting though. Why it has run here? Okay, let's do another way. Let's see. Now will it still run? Yeah. Now we're getting an error. Scanf mod C. Now we're getting an error, right? Got it. Yeah. Wait, what happened here? I think somebody pasted their code here, or what is that? Oh, cool. Oh, no, sorry. Do that part. Very strange. Chars, 1 second, scanf. Oh, wait, my bad. Should be this single quotes. Yeah, now I think it'll work. A. Okay, it still works. This is strange though. It should not be able to refer to this C over here. If I do this, just C, then does it work? Yeah. Makes pointer from integer without a cast. All right, cool. But it's still okay. Not sure why that is happening. Before star, it just means what the pointer can refer to. Technically, it should only be able to refer to a constant character. I think it's mostly upgrading this to a constant character. That's what it's doing. But I'll come back to you guys on this one. This is a good. This is what Ninja does. It gives you a lot of gotchas. So it's given a gotcha to us here as well. So I'll come back to you guys on this one. But overall, yeah, I'll let you know in the comments below, or in a future class. I'll let you know about this. I'll let you know why this is happening. But in theory, specifically, you can have before the star what the pointer can refer to, and after the star what is it? It's about the pointer mainly. Okay, so I hope that's clear. I hope that part is clear. We'll look into one more final question before we call it a day. Yeah, so let's look at it like this. This is the question, which is basically you're given a number and you're supposed to figure out if it's a palindrome or not. So let's look at this question. Given a number, you're supposed to figure out if it's a palindrome or not. This question, honestly, it's like a string question, so it's a pretty easy question. Okay, somebody wants me to repeat the previous part. Sure thing. This one, do you want me to repeat this? Which part would you want me to repeat? Can you tell me which part you want me to repeat here? So I'll repeat this. Do let me know which part you want me to repeat. Do let me know which part you want to repeat specifically. Entire code. Okay. I mean, that's what I just did, but I'll just start again. Okay. See, as per theory, at least. Okay. 1 second. Yeah. So as per the theory, let me tell you this. What we are doing here is we are saying const char star p is equal to c. Now, how do you actually read this code? You have to read it like this: before the star and after the star. Before the star, what we have is we have const char before the star. It means that it can point to a. What can it point to? It can point to a constant character, which was this case. 1, 2, 3, 4, 5 is what it was. It can point to a constant character, right? After the star tells you about the pointer itself. Can the pointer value be changed or not? That's what it can tell you, right? So after the star, we're talking about the pointer value. For example, had we kept over here const char star const p, had we kept const char star const p, it means that this p pointer itself cannot change value, right? What do we mean by that? If I did, let's say, p plus plus, just simple as p plus plus. That means I'm moving p forward. I'm not, I am changing the address it's referring to, right? So here, when I do this, I'll get error increment of read only variable p, because this const applies directly to this p over here. That's what it means. But the moment I remove this p can move anywhere as long as it's pointing to a constant character. It can move. So if I run this, it works. Okay. So this p can move anywhere, but it can point only to a constant character. That's what we did over here. It's pointed to a constant character. Now I got const char star q. It means it can point to a pointer which is pointing to a constant character. It's a pointer to a constant character pointer. That's what the star q is, right? And I said it's and p. So it is wherever p is, it's and p that. I said star q is a b c d e. So basically both p and q our value have now become a b c d e. Okay. Now I do const char star s is equal to plus plus p. So from here it's straightforward. P increases by 1. So from a b c d e, it's now pointing to b c d e. That's what p is pointing to. Now, although we change the value of p, s value did not change because s is still pointing to the previous value of p. Okay, s is still pointing to previous value of p, right? Because p you might have changed, but s is still pointing to that location, right? So then you did plus plus s. So it was b c d e. You changed it plus plus s. It became c d e, and now it will print c. Does that answer your question? Do you understand now? So it becomes c d e, and then c is like the character we're pointing to. So it's going to print this. Do you understand that part now? Let me know. And if you don't, it's fine because it's a C question, right? Clear? Super. Okay. Again, but it's a C question. There's a lot of gotchas in C. Now, like for example, we just discovered one gotcha here that how come this P is pointing to a non-constant character here. So I'll come back to you with that. Why it's pointing to that. So I'll come back to you with that. With that, we'll just stop with one last question, which is finding if a particular number is a palindrome or not. So if you take particular, they'll give you a number and you're supposed to figure out if is the number a palindrome or not. Okay. Super simple to do in Python, right? Like it's this simple. I take word is equal to input, right? And I don't even need to convert it to an integer. Let's say I take input.strip just to take out all the spaces, and I'll just check if word equal to word of, and you want to reverse it's this, right? If that is the case, print yes, else print no. So in Python, it's going to be super simple to do. So we got this here, and if I run this, it passes the test cases. Again, just checking if a number, if a word is care that it's a number or not. We're just converting it to it's reverse, and we're just checking yes or no. That's all we're doing, right? That's the point over here. Okay, but how do we do it in another language, right? So this for Python gives us all of this. How can we do it in another language? Again, if you just have to figure out palindrome, you don't even need to. Let's say I do it in C. Okay, you don't even need to convert it to an integer. You apply your same palindrome logic that you do for a word also. So they give you a number, you want to convert that number, you have to figure out if a number is a palindrome or not. We can do the same thing as we do with a string. Let's say void main, right? And I go like scanf modulo s, a particular word. And what is our word? Char word 1000. Let's say I create 1000, and let me find the length of the word. So in length, for length is equal to 0, length word of length not equal to null, length plus plus, right? And I found the length like this. How is this the length? I discussed this yesterday. You can get the length like this. And now you just have to find out if this word is palindrome or not. So how do you find out if it's palindrome? There are 2-3 ways. You can start at the end. You can start at the start. Keep comparing the words and keep comparing the elements. If they're equal, then you go forward. If they're not equal, then you can say it's not a palindrome. So let's say, for example, I say Boolean. Sorry, no, forget Boolean. Let's not go for Boolean. Let's say int pal is equal to 0. So I'm saying, or let int pal is equal to 1. I'm saying it is a palindrome. I start from for int I is equal to 0. I less than length by 2. I'll go to length by 2, I plus plus, right? Yeah, I less than length by 2, I plus plus. If word of I, this is your standard palindrome thing. If word of I not equal to word of length minus 1 minus I, then your pal is equal to 0. And you should break out here. If the pal is equal to 0, and you'll break. That means it's not a palindrome. But if it is equal, then you continue. Then you go on to the next element and the next element. What is this happening here? Well, for example, if you are given a string like 1, 3, 4, 3, 4, 3, 1, let's say you're given this kind of string, right? What we're doing is, let's say the indexes are, this is 0, 1, 2, 3, 4, 5, 6, right? So these are the indexes. So what we're doing is, length is 7, length here is 7. So I'm comparing 0 and 7 minus 1 minus 0, right? I'm comparing 0 and 7. Can we compare string with string of reverse? You can do that, right? I'm just telling you, if you didn't know any of these things, how do you do it? You can do it this way. So then I do 7 minus, then I do 1 with 7 minus 1 minus 1, which will be 5. Then I take 2, I compare 2 with 7 minus 2 minus 1, which is 4. I keep comparing them till they reach a midpoint. And if I came out of this, if pal equal to 0, I'll printf no, else I'll printf yes. Right? So one of them I'll print. So if pal is still 1, it means that it is a palindrome. Right? So 121 is yes, and if I submit it, it will pass the other test case also. So yeah, a pretty simple question. I wanted to keep today's final revision question to be. We've covered all of the difficult questions previously, right? So yeah, I'll just wrap up now. I'll not take more of your time. Let's just wrap up here about the thing. So today recap and some important points for you to know. Number one, we looked a little bit about pointers and we saw a very cool const char type pointers, const char concept. Check out constant pointers. You need to check this out. This is this is a concept that's definitely going to come in your exam. At least one MCQ is going to be there on this, so make sure you check that. We also check the concept of static. Again, one MCQ on this can come. Right? So there's a good chance that one MCQ on this can come. We checked out 2 questions that you guys had submitted, so thank you for that. Very, very good questions. One of the questions was regarding second largest element, right? And another question was a good one, which was converting digits into words and then counting vowels in words, and then again, counting pairs whose sum is sum of vowels, right? Whose sum is the sum of vowels. So it's a good question. It's a long question. It takes time. So when you get a question like this, try to take more time for it. Try to write down a full logic first and then only go for the code. This code will be long. This number 4, which we discussed, this code is going to be long. So make sure that you take your time with it. It's going to be at least like I think 60-70 line code. So make sure you start with it if you have the choice. So do start with that. Okay. And yeah, over the last few days, we've covered a lot of concepts like about strings, about binary to decimal, about maths and so on. So make sure you go ahead revise all of those concepts, right? And yeah, so we'll wrap it up here. If you guys have any doubts, please put them in the chat. Otherwise, do say clear, and then we'll wrap up. So please do say clear if you guys have any. If you're done, if you don't have any more doubts, do say clear. Okay. Just wait. Okay, super. That's good to know. Awesome. So everybody, first of all, thank you all for joining today. I know it's a festival, so thanks a lot for joining today. Um, Festival for all of us. So yeah, again, wishing you a very happy Ganesh Chaturthi. Hope it's all great. You guys have fun with family, and yeah, prepare well for TCS and Ninja. So tomorrow I have Gen Z Elevate exam. Which level of questions can come? Um, a little bit more difficult than this. The question that we just did right now about digit into words, that is a possible type of question that you could get. So that is the kind of question that you could get. I would suggest revise stacks, because like most of you already know arrays and all of that, but you guys don't know, like sometimes you guys miss out on stacks. So do revise stacks, right? And stacks especially nearest larger element, and infix to postfix. That is the level of question that might come. Otherwise it's just a little bit above ninja, but not too much. And one other thing is, make sure that at least for all Edyst students, we have enabled that you have this thing called automata fix, by the way. I'm not sure if they're going to ask you that automata fix. Last time there was when CTS used to hire differently. I think this year they have used differently, but just to hire differently, they used to have this thing called automata fix. So for everybody, we've enabled this. I would just suggest for all of you to go ahead and check out those questions, which were code debug questions. These are basically code debug questions. You'll be given a question, let's say fix array sum. So you'll be given a question where you're supposed to fix this. You have a particular output over here that's expected, and you're supposed to fix this code so that you get the correct output. Okay, it's very simple to do, but you need to do it once to understand it. So this is enabled for everybody who's an Edyst student, so don't worry about that. It's there. Oh wait, I was not sharing my screen. I think let me just share my screen again. Yeah, so it's over here. This is code debug questions. If I go here in code debug questions, it's like for example fix array sum over here. You're going to get a code which is half correct. It's not fully correct. If I run this, for example, I'm going to get some it doesn't match the expected output. Why? Because I'm supposed to take the sum of the array. I'm doing sum is equal to arri. I should be doing sum is equal to sum plus arri. Now if I run this will pass, and you can submit, it also passes. These are the kind of questions that TCS is known to have asked earlier. I don't know if they'll ask this time or not, but earlier they seem to have asked these level of questions. So go ahead and practice this. It's fairly simple, but you need to do it once. That's what I meant to say, right? So that's it. Okay, so with that, I'll close off. Again, everybody enjoy a festival. Have a great day ahead. My best wishes to you and your families. And yeah, I'll catch you all later. Thank you all for joining today, and wishing you all the best for TCS Ninja. If you guys crack it, please reach out to us and tell us. We help so many students. We always love to hear feedback from you, and we also love to hear whenever you get a placement opportunity. So if you get a placement through Ninja or any other company, do reach out to us. Tell us. It makes our team happy, and it motivates us to continue doing more and more. Right. So, right. Last question, actually, somebody saying if somebody wants to learn a framework, which should he or she select? Definitely, I would like JavaScript, Node, Angular, React. Okay, front end, I would suggest React because it has a lot of. It seems very like future proof. Like a lot in the future, people are going to use that. But again, as I always suggest, try to learn the concept, and if you learn the concept, then you can pick up any framework. And backend Node, you can't go wrong with that. If you're already learning JavaScript, then Node is good to learn, right? Okay. All right. Thanks all for joining today. And yeah, I'll catch you all next time. Thank you so much.